Okay, I am going to work through your problems on your scientific notation worksheet. So the first problem says the human eye blinks an average of 4,200,000 times a year. So the very first step is to write what we've been given. Okay, and we want to convert it to scientific notation, so the first thing is to figure out where the decimal is. Our decimal is here. And we want to have one whole number at the end of our problem. So that means we want the new decimal point to be right here. So we need to count how many times we need to bubble over to that point. So we have 1, 2, 3, 4, 5, 6. So we have 6 bubbles. So we rewrite our number with our new decimal point times 10 to the 6. Number 2. Computer processes a certain command in 15 nanoseconds. Okay, in decimal form this number is. And notice how when I write, I'm putting the numbers in groups of 3. That helps with us writing it down. Make sure we have the right number of zeros. Okay, so first step, here's where we're starting, and we want to go right here. So how many bubbles? 1, 2, 3, 4, 5, 6, 7, 8. So we got 1.5 times 10, and we got to ask ourselves, are we going to put a positive 8 or a negative 8? And so to return this number back to its original state, we're going to move to the left. So it's going to be a negative 8. Okay. Number 3. There are 60,000 miles in blood vessels in the human body. So we got 2 problems. We need to change miles to scientific notation and kilometers to scientific notation. So we'll start with miles. And we have 60,000. First step, find where we're starting, find where we're going to end up. 1, 2, 3, 4 bumps. So we have 6 times 10 to the 4th. Now it's just good practice to put this 0 afterwards, just gives a placeholder. And if we do it for kilometers, we have this many where we're starting. Oh, I wrote down too many zeros, didn't I? Sorry. Back up. Okay, so sorry I got ahead of myself doing a different problem. So where we want to start, where we want to end with one whole number. So we got 1, 2, 3, 4 bubbles. So then we end up with 9.7 times 10 to the 4th. Okay, number 4. We want to change both Celsius and the Fahrenheit number to scientific notation. So we'll start with Fahrenheit. See, this is where I pulled that number from when I made a mistake. Okay, where we're going to start, where we're going to end. 1, 2, 3, 4, 5, 6, 7, 8. So 8 bubbles. So we got 9.2 times 10 to the 8th. Remember, I want to see you do this. I want to see the bubbles, and then you need to rewrite your answer. Okay, let's do the Celsius. Where we start, where we want to end. 1, 2, 3, 4, 5, 6, 7, 8. So 5.1. And I'm just going to go ahead and leave that other trailing one on there just for kicks. Okay, this is probably a good approximation. We're not going to do significant figures in this unit. So, number 5. Now this has a lot of zeros in it, so this is where grouping by 3s is going to be important. So 0.123, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So let's see, 1, 2, 3, 4, 5, 6, 7 packets of 3. 1, 2, 3, 4, 5, 6, 7. And then 0, 0, 1, 6, 7, 3. So here we have a really small number, and we need to change it to scientific notation. So first step, find where we start, where we want to end. You would think it's right here, but we have this 1 here, so here's where we want to stop. So don't make that mistake of your eye forgetting where that 1 is. Okay, so count our bubbles. So we got 3, 6, 9, 12, 15, 18, 21, 22, 23, 24. So we have 1.673 times 10 to the 24th. Now we got to ask ourselves, do we have a really small number or a really big number? So we have a small number, so it's going to be negative 24. So hopefully you can see how grouping the 3's helped and then the bubbles helped. Okay, number 6. Now we have a big number. So again, we're going to group our numbers by 3. So we have 1, 9, 8, 9. And let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 3 it looks like. 1, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3. So that's 1, 2, 3, 4, 5, 6, right? 7, 8, 9. Am I going to make it? 10. Okay. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So where are we going to start? Oops. Here's where we're going to start, and here's where we want to end. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 31, 32, 33. So we have 1.989 times 10 to the 33. So when we're going to be talking in astronomy, it's going to be important because we don't have any idea in our head the distance to the sun in something we're familiar with, like miles or kilometers. So we're going to use scientific notation and other models in science to help us with those vast distances and the vast amount of times that we're going to be talking about. So this is 1 through 6, and there'll be another one on 1 through 7. See you soon.